Welcome back, students, to our geometry class. Chapter 2, Pythagoras Theorem, Part 3. Practice set 2.1, 7th sum. We read the sum first. In the figure 2.21, measure angle DFE is 90 degree. FG is perpendicular to ED. If GD is 8, FG is 12, then find EG, FD and EF. So we come to the figure. If you see here, this particular triangle DFE is given as a right angle triangle, and in this right angle triangle FG is a perpendicular which is drawn on the hypotenuse. Okay, and they have given FD here 8 and FG as 12. So first thing we have to find is EG. If you look at the figure, a right angle triangle and a perpendicular is drawn on the hypotenuse. So the property which we can use, and from the given information we have to find EG, we can use here the property of geometric mean. Okay, so we can start. So we begin here now. Solution. The figure is already drawn. So you'll write in triangle DFE, where measure angle DFE is equal to 90 degree. Okay. Therefore, and segment FG is perpendicular to segment, okay, ED. This is given. Therefore, by the property of geometric mean, we will use, therefore FG square is equal to EG into DG. Okay, FG square is equal to EG into DG. Now FG is given, that is 12 square. EG we have to find, and DG which is given as 8. Okay, we write the square of 12, 144, which is equal to EG into 8. Now we shift that 8 to the other side, so it becomes 144 upon 8. Okay, so we do the needful calculations, and what we get EG as? We get EG as 18. Okay, if you want, you can show the calculations, or you can do it on the rough and you can just write the answer. Okay, now first thing what we got is EG. This is the first what is asked to find. Now next is FD. Look in the figure, FD. Now if we want to find FD, we cannot use geometric mean here. Okay, but if you observe, FD is a side of a triangle which is a right angle triangle, that is FGD. And out of this 3 sides of FGD triangle, we know the 2 sides. So we can find the third one by which theorem? Pythagoras theorem. So you'll write in triangle FGD, measure angle FGD is equal to 90 degree. Therefore, by Pythagoras theorem, please use Pythagoras theorem here. So if FGD is, this is 90 degree here, Pythagoras theorem, the hypotenuse square. So FD square is equal to GD square plus FG square. So I'll write down here FD square is equal to FG square plus GD square. Out of that, FG and GD we know 12 square plus 8 square. Therefore sign. Okay, so we write 12 square is 144. This is 64, which is equal to 108. So you can write therefore FD square is equal to 208. Now we want FD, so taking square root on both the sides. Okay, FD is equal to, if I take square root of FD square, square and square root gets cancelled and I get FD, which is equal to 208. Now how you will solve this 208? If you know directly the factors, yes, you can put the factors directly. But for those who don't know the factors, so you can do this in the rough. I can show you in the rough page. Okay, you have to do it in your rough page. You have to find the factors of 208. Okay, some will know directly the factors with a is a square, and you can use it. But the one who don't know, okay, in your rough side or in a rough page, you will solve this, find the factors. So you have studied this in the lower standards. So 2 1s are 0s are 2 4s are 8, 2 5s are 10, 2 2s are 4, 2 2s are 4, 2 6s are 12, 2 1s are 2, 2 3s are 6, and 13 is a prime number, so 13 1s are. Okay, and now what you have to do is you have to take this a pair of the numbers. So what did you get here? 2 2 2 2 and 13. So you know that you have to take the pairs. So this becomes as 4, this becomes as 4 and 13. Okay, so what are the factors here? 4 into 4 into 13. So you just have to write the factors and then you make the pairs of same numbers. Pairs means 2, okay, of same numbers. So 2 into 2, 2 into 2. So 2 2s are 4, 2 2s are 4. Clear? Into 13. Now 4 into 4 is 16 into 13. 16 is a square. Okay, so basically when you are finding the factors in the root sign, you should get a square so that you can take it outside as a square root. So here what 208, we got the factors as 16 into 13. So how will I write this? 16 into 13. Now 16 will come out as 4. Okay, because 4 4s are 16. So when I take it out of the root sign, it becomes 4. The 13 remains same because it's a prime number. So this is your answer. So some may directly know that the factor of 208 is 16 into 13. They can do it directly. No worries. Okay, and this is your answer. So this is the second thing what we have found. So I should give this number 2. Yes, number 2. Now this is the second thing. We still have to find EF. Now we'll see where is EF. This is EF. Okay, so how do we find EF? In our first statement here where we found, we got EG as 18. Now we have to find EF. Now how we'll find EF? If you see here in this triangle EGF, in this EGF, it's a right angle triangle. Yes, we know two sides of the right angle triangle, correct? And we can find the third side very easily by using Pythagoras theorem. Okay, so this third one I am not going to do and it will be for homework. So the third, that is to find EF, okay, is for homework. This you all do on your own. And at last, when you find all the three, you will put number 1, number 2, number 3 and you will write all the 3 answers. Okay. So how you will find EF? Simple again. Here I will just explain you again in the figure. That is, if you see triangle EFG, measure angle EFG is 90 degree. Therefore, by Pythagoras theorem, EF square is equal to EG square plus GF square. Out of this, GF is already given 12. EG we found it is 18. In the first thing, what we found, EG as 18. So you can use that EG as 18 and you can find EF by Pythagoras theorem. I hope it is clear and you will do this third one for homework. Now the next sum, 8th one. Find the diagonal of a rectangle whose length is 35 centimeter and breadth is 12 centimeter. Okay, for that we will need a right angle triangle. They have not given, so we need to take this right angle triangle, a rectangle. Okay, we have to take this rectangle. Maybe this is A, B, C, D. You can put any name, A, B, C, D, as a rectangle. So we have taken this in quadrilateral A, B, C, D. Okay, solution. Quadrilateral ABCD is a rectangle. And here the length and the breadth is given. Okay, length is, here in this figure, length is DC and AB, which is 35 centimeter, and breadth is BC and AD, which is 12 centimeter. So you'll write DC is equal to AB is equal to 35 centimeter and BC is equal to AD is equal to 12 centimeter. Now we have to find here the diagonal of the rectangle. That is, we have to find BD. Now if you see in the figure, we have got a right angle triangle. Okay, and we know the two sides of a right angle triangle, so we can find the third very easily by Pythagoras. So how we are going to write? In triangle BCD, measure angle BCD is 90 degree. Now who has told us this is 90 degree? Yes, it is an angle of a rectangle. Or you can write the property of rectangle, anything. And therefore by Pythagoras theorem, okay, use Pythagoras theorem here. That is BD square is equal to BC square plus DC square. Okay, out of this BC is 12 square and 35 square, and then you will proceed. Okay, so here 12 square maybe you will know, that is 144, but 35 square if you don't know, you all can calculate in the rough and you can put what is 35 square, and then you will add same method by taking square root on both the sides, and then you will get the final answer. Now once you get BD, okay, once you get BD, what is BD? The diagonal. But don't leave your answer writing that BD is equal to so and so. Okay, you need to write the final answer as, therefore, after you do all the calculation, again this calculation is for homework. Okay, this calculation is for homework, and then final answer you will find what is BD. Once you get what is BD, you will write that answer, and you will not leave the answer there. You will write the final answer. Therefore, the length of the diagonal of a rectangle is so and so centimeter. This calculation you all have to do. As I told you, 35 square, please multiply and find. And after you find, you have to add 12 square and 35 square. And whatever is the answer, you have to take square root, because you will get BD square equal to. Okay, and we want BD. So you will take square root on both the sides. If it is a very big number, then as I showed you how you will do by factor, you will find the factors and you will solve. You are in 10th standard by now, you all should know this calculation. Now moving to the next sum, that is a 9th sum. They have given the figure, and in the figure 2.22, M is the midpoint of QR. So M is the midpoint of QR. It is given here with this particular signs. Angle PRQ is 90 degree. Prove that PQ square is equal to 4 times PM square minus 3 times PR square. Now we have to prove and you have to get this statement. Okay. Now, given in the figure itself, the information is given. So we proceed. I have drawn the figure here. So we will start. Now, one thing given is, that is, this angle is 90 degree here, angle R. M is the midpoint of RQ. One thing you will observe, there are two triangles here which are right angle triangles. Okay, with the help of this measure angle R equal to 90 degree, we get two right angle triangles here. One triangle is triangle PRM and other triangle is triangle PRQ. Both are right angle triangles. And what we have to prove here is something PQ square equal to PM square and PR. Looking at this, okay, and since we are having right angle triangles, in order to get this square, we have to use Pythagoras theorem. So always remember, children, you will get many sums like this where you have to reach to this sum conclusion, proving it. Left hand side equal to right hand side. First, look at the given information, look at the figure and look what is asked to prove. And how will you come to this conclusion with the help of this given figure or information? It requires some squares and that we can get only from Pythagoras theorem. Okay, so let's begin. So, since there are two triangles, we'll use any, we'll start with any one. So, in triangle PRQ, the bigger triangle, angle PRQ is equal to 90 degree, which is given. Okay, therefore, by Pythagoras theorem, okay, how do we use Pythagoras theorem in this triangle PRQ? So PQ square is equal to PR square plus RQ square. PQ square is equal to PR square plus RQ square. Now, you can take this as statement 1 because there is one more triangle where we have to use Pythagoras. So we can do that. That is in triangle PRM, where angle PRM is also 90 degree. Okay, which is given. It is the same angle with different two names. Both the names are different, PRQ and PRM, but it is one and the same angle. So therefore, by Pythagoras theorem, okay, we'll use Pythagoras theorem here. That is PM square is equal to PR square plus RM square. We can give this as statement number 2. Now we used Pythagoras in both the triangles. Now somewhere we have to reach to the thing what is asked to prove. That is, again I will show you here. PQ square equal to 4 PM square minus 3 PR square. So now what we do is, there is one more information given, that is M is the midpoint of RQ. Okay, if M is the midpoint of RQ, here if you see RM, we can write RM is nothing but half of QR. Okay, RM we can write it is half of QR, or RM is half of RQ. Okay, so just after this I can write here, therefore since RM is half of RQ. Now why do we write that RM is half of RQ? Because M is the midpoint of RQ. Okay, so if RM is half of RQ, can we substitute RM here in statement 2? Because as it is what is asked to prove, we don't want RM. Okay, the statement what we want, final statement, we want PM, we want PR, but we don't want RM. So we will remove that RM. And how do we remove that? By substituting RM is nothing but half of RQ. Okay, so we can give this as statement 3 and we can write here substituting statement 3 in statement 2. So we are just substituting this third statement in statement 2. So what will the statement 2 become now? PM square will remain the same, equal to PR square will remain the same. Only thing we have to substitute is RM. And RM square we are substituting with this. RM is equal to half RQ. Now we are substituting RM is equal to half RQ. But here it is not only RM but it is RM square. So if it is RM square, we have to write here half RQ the whole square. Because if RM is equal to half RQ, RM square will become half RQ the whole square. Most of the time children make mistake here, but by just writing half RQ square. It is half RQ the whole square. Square is also for half. Because RM square and RM is half RQ. So when you take the square of RM, this whole thing square we have to take. Now we proceed. PM square is equal to PR square plus half square becomes 1 upon 4 and RQ square is RQ square. Now we have a fraction here, numerator and denominator, but what is asked to prove doesn't have anything in the numerator. It has just the numbers. So what we do is we multiply with 4 on both the sides to each. Okay, so here 4 with each term. Okay, so if you multiply 4 everywhere, we multiply 4 here, this becomes 4 PM square. We multiply 4 here, so it becomes 4 PR square. And when we multiply 4 to this, 4 and 1 upon 4 gets cancelled. Okay, and therefore we just get RQ square. I hope this is clear. Now if you look at this, what we have got and what is asked to prove. Okay, what is asked to prove is PQ square is equal to 4 PM square minus 3 PR. So there is PQ, there is PM and there is PR. So there is PQ, PM and PR. Now out of this, we want PM, we want PR. But we don't want RQ. Instead of RQ, we want PQ. Okay, so how we can remove this RQ and we can get PQ. So come to statement 1. Okay, so here RQ is there, which we want to remove. Okay, and instead of that we want PR. So this first statement we can convert to RQ equal to. Okay, so I write that statement 1 first. Okay, so that is PQ square is equal to PR square plus RQ square. This I can write as statement 1. Okay, now this I will make it as RQ equal to. So if I make this RQ equal to, I have to shift the PR on other side. So PQ square minus PR square is equal to RQ square. Now this RQ square I will substitute in this. Okay, therefore RQ will be removed and I will also get PQ, which I want, which was missing. Okay, RQ I didn't want, and instead of RQ I wanted PQ. So I took the statement 1, okay, and I just shifted PR to the other side and I got this RQ. So this RQ square will be replaced. Okay, so maybe you can write this as statement 4 and this you can give statement 5, and you can write that substitute statement 5 in statement 4. Okay, I hope you can see. I have given this as statement 4, which I want to replace RQ, and this RQ equal to statement 5, which I got from statement 1. Statement 1 I wrote as it is and I just shifted. Now this RQ equal to I will substitute here. Okay, and then what I'll get this fourth statement as 4PM square is equal to 4PR square plus, instead of RQ, I don't want RQ. So I will replace this, instead of RQ I'll write PQ square minus PR square. Okay, so this RQ which was there, I'll just show you with colored. I'll just show you with the colored this, that this RQ which I didn't want, this I have replaced with this thing here. Okay, and that I have substituted, instead of this RQ I have put here, which I have written here. Now I'll just try to solve this. If you see here, 4PM square is equal to 4PR square and minus PR square. Minus means 1 it is. So 4PR square minus 1PR square is 3PR square plus PQ square. Now we'll just see what we are asked to find, or we have to prove. We have to prove PQ equal to. So we will just make our statement according to what they have asked and what they want. They want PQ equal to, okay, so we can shift this to the other side, PR to the other side. So it becomes 4PM square. This if I shift it is minus 3PR square is equal to PQ square. And they wanted PQ square equal to 4PM square minus 3PR square. Yes. Only thing I have to just shift the left and right. So this PQ square I will bring to the left hand side and this whole thing I will take it to the right hand side. So therefore PQ square is equal to 4 PM square minus 3 PR square. Okay. So this is what is asked to prove. Is proved. So every time you have to keep in mind what is asked to prove, and accordingly we have to make the changes. Okay. So after this substitution, I hope you have understood this substitution. I didn't want this RQ, so I took statement 1 and I just made it RQ square equal to, I shifted this PR here, and this RQ equal to whatever I have got, I have just put in this statement 4. And then after what I get, after solving, after substituting, 4 PR square minus 1 PR square is 3 PR square plus PQ. And then just shifting, because the way they have asked, you have to bring it to that. So PQ equal to I want. So I shift this 3 PR square to the other side. Just go through it. Now the last sum from practice set 2.1. The 10th one. Walls of two buildings on either side of a street are parallel to each other. A ladder 5.8 meter long is placed on the street such that its top just reaches the window of a building at the height of 4 meters. On turning the ladder over the other side of the street, its top touches the window of the other building at a height of 4.2 meters and find the width of the street. Okay, so here looking at the sum, we will need the figure. Okay, without figure we cannot solve. So I have drawn the figure for you all. So if you have heard the sum properly, you will come to know that there are walls. Okay, so the walls of two buildings. So I have represented the walls with these straight lines. Naturally the walls of the building will be standing erect on the ground. Okay, so you can give some names. So maybe AB and PQ are the two walls of the building. They are such that a ladder which is 5.8 meter long is placed on the street such that it reaches the top of the building at 4 meter. On turning to the other side, it reaches the other building at 4.2. Now what is this? So there is a ladder which is kept on the street, and when we move that ladder to one building, it reaches the one building at a height of 4 meters. So if this ladder is maybe AC is a ladder. So if AC is a ladder which is moved to the left hand side, it reaches the building at point A, and this AB height is 4 meters. And when the same ladder is moved to the right hand side, it touches the other building at this position P, such that the length PQ becomes 4.2 meters. Okay, the same ladder is being moved, and therefore the figure which we get is this. And the final thing is we have to find the width of the street. Width of the street means between these two buildings. So AB is one building and PQ is another building. Okay, so here now they have not given perpendicular or anything, but we know that the building is always erect, making an angle of 90 degree with the ground. So we have taken this as 90 degree. Okay, now before we begin, we have to write all the assumption what we have taken, which is the building, what is the position of the building, the position of the ladder, everything. And we have to find the width. We have to find the width means we have to find how much is BQ. Okay, so we begin. We can write in the figure. In this figure, particular figure, you can also give some names here. For example, D and R. So we can say that DB and RQ are the representing the walls of the building. Okay, and the ladder which is there on the street, when it touches one building, it reaches to a point A. Okay, and when the ladder is moved to the other building, it reaches to the point P. So it is up to us what we have to take. So we'll write in the figure segment DB and segment RQ. DB and segment RQ. Okay, represent the walls of two buildings. Okay, and now there is a ladder. The ladder is same. So first position the ladder is AC and the second position the ladder is PC. So the ladder which represents the first position is segment AC, and the second position is segment PC. Okay, and we also write segment AB, or we can write segment DB is perpendicular to segment BQ, that is the ground, and segment RQ is perpendicular to segment BQ, that is the ground again. We also need to write AC is equal to PC. AC is equal to segment PC, that is the ladder, which is 8 meters. It is given meters. Okay, and they have given first the ladder reaches to the position A, where AB is equal to 4 meters, and the second ladder which reaches to the position P. First ladder reaches to the position, when the ladder is brought here, it reaches here, so AB is 4. The same ladder, when it is taken to the other side, it reaches the position P, and the height where it reaches from the ground is segment PQ, which is 4.2 meters. Just go through all what we have written and the figure. So we can proceed. Now we have to find the width of the street, that is between these two buildings, this street. So we have to find BQ. It is not possible for us to find BQ straight. But yes, if you see, there are two triangles which are formed and both are right angle triangles. And if they are right angle triangles, we can use Pythagoras theorem. Okay, and now in this Pythagoras theorem, in both the triangles, we know two sides. So it is easy to find the third side. And if we add the third side, we will get the street, width of the street. So we start in triangle, first triangle ABC. Okay, here measure angle ABC is 90 degree. Okay, therefore by Pythagoras theorem, so I am talking about this triangle here, ABC first. Okay, now using Pythagoras, AC square is equal to AB square plus BC square. So I write here AC square is equal to AB square plus BC square. So AC square is 5.8 square, AB square is 4 square plus BC square. Therefore, 5.8 square is, you can find it out, 33.64. Okay, you can do the calculation. 4 square is 16. I shift 16 to the other side, so we get BC square is equal to 33.64 minus 16. So again, so BC square, you will get it as 17.64. Okay, and therefore by taking square root on both the sides, okay, what you get is BC, which is equal to 4.2. Now this calculation you all can do it in the rough. Okay, so when you calculate 17.64, you can find the square root and you will get it as 17.64. Okay, now This is BC, that is we have got this. Now we need to find CQ as well. Okay, now how you will get CQ? Again by same method, taking square root, taking the Pythagoras theorem in triangle PCQ. So I'll just write down here, in triangle PQC, major angle PQC is equal to 90 degree. Therefore by Pythagoras theorem, PC square is equal to PQ square plus CQ square. I will just show you the figure one more time. By using Pythagoras here, PC square is equal to PQ square plus CQ square. Out of these two things we know, we will find the third one. Okay, so we'll just substitute. PC is 5.8 the whole square, PQ is 4.2 the whole square plus CQ square. Okay, so 5.8 is just now in the beginning we did, but 5.8 is 33.64. Okay, 4.2 square is 17.64 plus CQ square. Okay, now just putting therefore sign, we just shift this, so we get CQ square is equal to 33.64 minus 17.64. Now you can do this calculation, okay, and what you get is 16. Okay, and therefore CQ, taking square root, please mention here, taking square root on both the sides, CQ you get it as 4 meters. Okay, here we got BC as 4.2 meters and CQ we got, so BC and CQ both we got. Okay, if you see here BC and CQ, we got BC as 4.2 and CQ as 4. Now we will just add to find the width of the street. So what we write here is, okay, the street is BQ. BQ is nothing but BC plus CQ. Reason you can give B dash C dash Q in the figure we have taken. After that BC is 4.2, this is 4, so answer is 8.2 meters. Okay, so BQ, which is the width of the street. So we cannot end the answer with BQ because they have given in the question, find the width of the street. So therefore the width of the street is 8.2 meters. I hope this is clear. Okay, so it's difficult to show in just one screen, but you can go through it. Here we have taken DM and RQ as the walls of the building. AC and PQ is the same ladder which is on the street. When it is brought to the left hand side on the building, it reaches point A, such that AB is 4 meters. And when the same ladder is brought to the right hand side on this wall, okay, it reaches point P. And the PQ becomes such that PQ is 4.2 meters. Therefore, the ladder size remains the same ladder. AC and PC remains the same. And we have to find the width of the street between these two walls. So we have to find BQ. First we'll find BQ, then we'll find CQ. And that will BC and CQ. And that will give us the full width. So first we took the triangle ABC, which is a right angle triangle. We also said why it is a right angle triangle, because the wall is erect, making an angle of 90 degree to the ground. Therefore, right angle triangle by Pythagoras theorem, AC square equal to AB square plus BC square, and the full calculation is here. I'll show you. Yes, here. Okay, yes, it is having decimals, so the calculation may be a little tedious, but it is not difficult. So you can take 58 square, and whatever is the answer from behind, you can put 2 decimal point. Okay, and 4 square is 16. Then you subtract. When you subtract, you do it in the rough work, subtract, you get 17.64. Now to get the square root of 17.64 is also not difficult. Okay, what you can do is, you can convert this 17.64. I will show it on the rough page. Okay, this where I showed this 17.64, when you have to find square root, you can convert it to 1764 divided by 100. Okay, now by this method you can find the factors of 1764. You can write the factors here. Okay, and you know the factors of 100, 10 upon 10. Okay, and 10 into 10, sorry. And then whatever factors you get, you write the factors and then you can take the square root. Okay, so if we want, I can just show you here. So this is 2, 8 is 16, 2 8 is 16, 2 2s are 4. Okay, then 2 4s are 8, 2 4s are 8, 2 1s are 2. Now this is divisible by 3. So 3 1s are 3. Okay, 3 4s are 12. 3 7s are 21. Again this is divisible by 3. So 3 4s are 12. 3 9s are 27. 7 7s are 49. 7 1s are. So what are the factors here? You will see this space, what I told you, no? So what you get here, it is 2 into 2 into 3 into 3 into 7 into 7. So this and this. So when you take the square root, you write this 2, you write this 3, you write this 7 and this 10. Okay, and therefore what you get is 7 3s are 21 and 21 2s are 42 upon 10, and that is 4.2. Sorry, 7 3s are 21, 21 2s are 42, 42 upon 10, it is 4.2. Okay, and this 4.2 has been written here. So there are many ways of doing it, so it's up to you. After we get BC, we take the another triangle. Okay, here we use Pythagoras again. PC square equal to PQ square in plus CQ square. We substitute this both, as I can show you here. Okay, again there is a decimal, so as I said, you will do it in the calculation part, and then you get this subtraction 16, which is easy. 16, you know, it is 4, and then finally we just have to add it, where you get the final answer. I hope it is clear to you all. Homework: complete the sums from practice set 2.1 which was solved in this video in your notebook. Thank you.